So here's our equation. Here, I'm just gonna label them so it's easier for me to see and label things. There's my x, y, z. Okay, so finding the divergence to measure if it's net outward or inward flow. And for that, here's our equation, so our derivative p with respect to x, our derivative of q with respect to y, our derivative of r with respect to z. So I'm gonna go ahead and do that. So the derivative of our p, here's our p right here. Let me put the laser. So if our p is right here, so it's the derivative of p with respect to x. Since there's x squared and a y, our y will be treated like a constant. So we break down the 2. So I'll go ahead and put 2x, and then we just leave y since they're together. Derivative of q with respect to y, there is a y variable. They're together, so you would just drop the y and leave our constant, which our constant is z. Then we do the derivative of r with respect to z. And there is a z, so same thing. Our z is a variable, so we bring down the power to z, and then our x does stay. So I'll put 2zx. Okay. So we are gonna do, oops. Actually, we go back to purple. So now we're gonna do our function of our points, because to find the divergence, we need to plug in our points. So x, y, and z, and we're just literally gonna plug in our x, y's, and z's into our partial derivatives that we just found. So 2 times my x, 1, my y, 2, plus my z, 1, plus 2 times 1 times 1. So 2 times 1 times 1 is 2, plus 1. 2 times 1 times 2 is 4. 4 plus 1 is 5 plus 2 is 7. So this is our divergence. Now, since our divergence is positive, that means it's going to be net outward. Very important. Now, second part is find curl. The curl equation is finish writing it out. So the derivative of r with respect to y. I like writing it like this too. Doesn't matter. Okay. So let's look at our r. So the derivative of r with respect to y, right here, no y variable. So this is all a constant. The derivative of a constant is just 1 or 0. So this is 0. Actually, I'll go one lower. 0 minus the derivative of q. With respect to z, there is a z. So we drop that z. Z minus, 0 minus y, comma, okay, the derivative of p with respect to z. There is no z variable, so it's all just a constant. Derivative of constant 0. Derivative of our r, let me find r with respect to x. So we do have an x there. So we can go ahead and drop our single x. Derivative of q, there is no x variable, so 0 minus derivative of p with respect to y. Let's see. There is a y attached to the x squared, so x squared is our variable, we just drop our y. Okay, so now we're gonna do function plugging in our points. So we can go ahead and start plugging in our points. So negative y. Y is 2, negative 2. Negative c is 1. Negative x. Oh, this is squared. Negative x is also 1 squared. So this turns out to be negative 2, negative 1, negative 1. So here are our vector points, and we can see this does not equal to 0. And our curls measures the local rotation or spinning tendency. So if we have a non-zero, which we don't have a non-zero, this does not equal 0, that means it's a local rotation. So here are our answers. So nets outward rotation at these points.